let me write it. Thermal emission. I will write a differential form because, well, why is it? Well, if I have a satellite like this, and the solar radiation and also the drag, both of them make the satellites to get warm. When they get heated, they start emitting the energy from themselves. And this emission can create some movement, small movement in the space. So when the satellite is getting heat, then it can be influenced by this acceleration. How can we compute that? I will write this in the differential form. Into that, then I will just foresight is finally right. It's minus 2 epsilon sigma T4 and 3C and that is the unit vector. I say the U and ds. dr. dr is the cross section again. So if the satellite is in that form, for example, if it is it's like planar like that, it is perpendicular to this. And U is the unit vector to the surface. C is the speed of light. T is temperature in Kelvin. And sigma, Stefan Boltzmann, Stefan Boltzmann constant. It's a constant. And this constant is, let me write it with another color. Constant 5.67 times centimeter square Kelvin. Okay. And epsilon is 1. It depends on the color. Is 1 for black. Surface. So you see that even the color of the satellite is important. Speed of the light and temperature with the power 4 and the cross section of 4. Larger area, more effect. Larger temperature, more effect. Darker, more effect. Yeah, that's it. So for the non-gravitational forces, we have solar radiation, a drag, and thermal effect. So then we know. Therefore, I can write the